Welcome back to the Coral Reef Virtual Symposium. Our next speaker is Beatriz Diaz-Guijarro. Beatriz, can you please share your screen and turn on your microphone and your camera? Beatriz is from James Cook University and her talk is on regeneration in Heliofungia. And a quick reminder, if you have a question for one of our speakers, please type it in using the Q&A box at the bottom of the screen at any time during their talk. Thank you so much, Beatriz.
Hi everyone. I want to talk to you guys a little bit about some of the heat and injury related regeneration experiments I've been doing lately. So, if I get moving. So I'm going to talk to you about Heliofungia tentacle injury first, then I'm going to go over some heat stress or heat shock experiments, and then what my next stage is on my research. In my PhD at the moment, I'm doing a mixture of corals, but Heliofungia is the one that I'm mainly doing my experiments on. So a little bit of background on Heliofungia. For those of you that don't know, it is a solitary fungid coral. It's also considered a mushroom coral, and sometimes people confuse it with an anemone because of its tentacles, how it moves. It can move a little bit, but not very much. They don't tend to like go for walkabouts or anything, but they do tend to move a little bit, which is why people also confuse them with that. They both feed on succinylate and heterotrophic feeding. So basically they either use a photosynthetic organisms and zooplankton that goes into the mouth. You can see with the green one, you can see the mouth in the middle. And that's where the feed technically goes into. If otherwise they use sucs. They're also sexual and asexual reproduction. So they either let out eggs and sperm into the atmosphere and reproduce that way, or they grow polyp buds. And it's pretty cool. Recently I got to see what that looks like, and it basically has like this tiny little coral on top of a bigger coral that it's growing, and eventually it drops off and it becomes by itself, which I thought was pretty cool anyway. They're also hermaphrodites and they have immense regeneration ability, which is why I'm working on them. So my first experiment, I did it at Ames. They have a huge amount of Heliofungias, most of which were born from polyp budding, from a bunch of corals that Aurelie Moya, one of my supervisors, collected from Orpheus in 2015 for an experiment that she did. She basically left them at Ames, and they've been reproducing through polyp budding ever since. So they've been there for a good 5 years or so. So I conducted this experiment with their stock. I used 4 of their corals, and I set it up in Cesium. I set up 2 tanks, each housing 2 corals, at 27 degrees Celsius and using daylight hours. This experiment took place last year in June 2019, and the idea was that I was going to do the major experiment in March, but for obvious reasons I couldn't go and collect corals from Orpheus, so it got a little bit pushed back. Anyway, I took 12 tentacles the first time I did the experiment, but I redid it a few times. Each time I increased the number of tentacles that I cut, and I got them from different areas. For example, at one point I took them closer to the mouth, sometimes I took them further away from the mouth, in order to see if there was any, if there's a difference in growth. Because the point of this experiment and my other one is basically to come up with a time frame for my main experiments for my PhD. So most of the information that I got from this experiment is due to photographs and videos. So a lot of photos, a lot of videos, and once I finished the experiment, I basically did a lot of photo analysis. So the results, here, I'm going to put a little video while I talk, and it's a little time-lapse video that I put together with all the photos that I took of the corals. And you can see how it goes from the fresh cut, which is almost like a shrunk up sock with an opening. In 2 hours, it grows a little rough patch, or a scab, as I call it. And within 24 hours, it has this little bumpy side, which basically smooths over the rough patch. And 48 hours later, you can't tell where the cut was at all. It's just completely smooth. 4 days later, the tips start to grow, and then 10 days later, the tips are completely reformed, so essentially regenerated completely within 10 days. The length of the tentacles grow a little longer. They take a little longer to grow, I mean, but the actual regeneration part is finished within 10 days, essentially. When I did cut the corals, I noticed that no matter what time of day I did it, whether it was first thing in the morning or last thing before the lights went out for them, they needed the night in order to grow this little bumpy side, in order to go from the rough to the bumpy. As you can see now in the video, it's gone dark, and that's when the right light comes in, and they all kind of shrivel in. And I believe it needs this this stop of energy in order for them to be able to finish the regeneration process, at least from the scabbed, from the rough patch to the smooth little bump. So the idea, the time frame that I came up for my large experiment is basically to do the first cuts, and I'm taking more samples since 2 hours, 24 hours, 48 hours, 4 days, and finally 10 days. I looked at other corals and through other papers and other research, and I found that actually their time points are very similar to the Heliofungia, so there is some overlap there with other corals. So my next experiment was a heat shock experiment. This one I started around March of this year, so literally 2 or 3 months ago. I picked up 3 corals, and I acclimated them to 26 degrees Celsius. I then, after 2 or 3 weeks, when they are completely acclimated, I increased the temperature by a degree per day to a maximum of 32 degrees Celsius. I then watched them, photographed them, took videos. I also took pan thermometer readings in order to find out what the number of Suks, if it was dropping. So what I found was, you see, I had the 2 main corals that I used, because the third one was a control. There was a large one that was 20 centimeters, and the small one was only 5. Because I was stuck on where to get corals from, I had to get them from a local aquarium, so this was what they had available. And I found that basically the small one took longer than the large one to bleach. So the big one took 3 days to bleach at 32 degrees, while the small one took 5 days to bleach, which goes in tow with what Deborah said earlier on today, that the juveniles take longer, which was interesting. Currently, they're still bleached. They don't look like this right now. Their tentacles are completely out, so they look pretty happy, other than the fact that they're completely white. We are playing around with the idea that we may have to reinfect them with symbiodinium in order to try to get them back to health. But they are getting fed and they are eating, so I imagine that's because we're feeding them zooplankton. I imagine that's that type of feeding that they're able to do. So they're still alive, and they still seem pretty happy, like I said, other than not having symbiodinium in them at the moment. So 2 weeks ago, I finally managed to make it to Orpheus to collect corals for my main experiments. So I picked up 12 helios of about 20 centimeters each, and I brought them back to Marfu. They're currently at JCU acclimating. They've been there for a little over a week now. And I took some samples while at Orpheus in order to do some genotyping on them, because we want to make sure that they're not related. So we want to make sure they're not buds or clones, even, because they can be considered clones when they're budding. So while they're acclimating, I'm extracting the samples, and I'm going to send them off to get whole genome sequencing, which will give us a whole heap of information that will be very interesting to look through and see what we can find. So my next stage now is currently they're acclimating for about 2 weeks, and then I plan to do the tentacle injury regeneration experiment. So I will take the time-0 samples, which will also account for the time-0 for the heat shock experiment, as it will be before anything has happened to them, anything that I've done to them. And so yes, you can see there I will follow on with the experiment that I found, and then they will acclimate again for 2 to 3 weeks, and I will start the heat shock experiment. At the moment, we're thinking about maybe increasing it by a degree every second day in order to see them bleach a little bit slower, hopefully. As summary, like I said, we found I managed to get a time frame out of the tentacle injury experiment. They take a maximum of 14 days to completely regenerate. And the heat shock, 32 degrees seems to be a good temperature for them to bleach out quite quickly. They tend to take 3 to 5 days to bleach, depending on the size, or I guess age. And so far it's taken longer than 30 days to get them to not bleach. So my next stage, like I said, I'm acclimating, then we're going to restart. I'm going to do the two big experiments and send it all for sequencing and see what information I get out of them. I'd like to thank Orpheus Island and especially Ames. They've been great help with my palettes and allow me to do things to their corals. And that's it. Any questions?